going to start with a handful of slides. I promise to keep this brief. And first off, what I'd like to do is kind of go backwards a little bit and talk about some of the things that we're hearing from industry experts with regards to manufacturing. You know, in today's manufacturing world, you certainly, I'm sure, have issues, situations that hopefully we can help you with. And if you look at this graph, very, very simply, if you're in a build-to-order, make-to-order, engineer-to-order environment, you're going to have more issues than someone that's doing repetitive manufacturing. And scheduling becomes a huge piece of that difference. What differentiates you from other manufacturers? So, you know, in the manufacturing world, there's planning and there's scheduling. And unfortunately, planning and scheduling don't always coexist well. You know, planning a manufacturing environment is much different than the scheduling side of things. And this graphic is simply to point out how those differences affect your world on a daily basis. In a typical make-to-order, engineer-to-order, some of the things that I've seen over the years in these environments is that if we could simply sit down and schedule for a week or 2 weeks and not make any changes, our lives would be so much more simpler. However, that's not the real world. The real world is I may need to go through, based on demand changes and customer requirements, I may have to go back through and reschedule numerous times during the day. And that has sort of been the concept of visual scheduling across its life cycle. So a typical scheduling process, whether you're engineer to order, make to order, or one of those repetitive type manufacturers, you know, there's a process to scheduling. You load in the orders, you try and consider the material and production constraints, the things that are going to affect the schedule, and optimize it so that you get the best use of materials and operations or resources. You then simulate the impact of any short-term changes, and those short-term changes could literally be minutes, and then provide a sequence of orders that you can release to the shop floor that will satisfy your customer's requirements. Visual scheduling takes all of this functionality into effect as it goes through and does scheduling. We look at capacities of resources. We look at materials. We look at our labor force. We look at our tools and jigs and fixtures and the things that are required in order to schedule efficiently for your environment. We can run finite capacity as well as infinite capacity. We can do optimizations. We can do product sequencing. Material replenishment and receipts have a huge effect on scheduling, and that is one of the functions that visual scheduling takes into account in regards to scheduling your shop floor. I have been into companies where they spend 4 hours a week in meetings going through and getting updates. Here's materials that are going to be late. Here are the materials that are going to be early. Here is an update on our labor force in terms of who's going to be in the plant for a given number of days. So visual is uniquely set up to do exactly that, and take those material requirement changes, to take into account those labor changes, and then reshuffle the deck, reshuffle that scheduling deck so that the information that we're putting out to the shop floor is the information that we need to provide them in order to keep our customers happy. Visual is also very uniquely built to do things like bottleneck identification and capacity management. And in effect, at the bottom line, when we tell a customer that they're going to have product on a specific date, Visual can do that. It can give your users that ability to go through and do some modeling and take the information that we get from that modeling and then give our customers promises that we can keep. These are the benefits of scheduling, and each one of these is addressed with the visual product. Cost reductions, improved asset utilization. If I've got a $200,000 machine sitting out on the shop floor and it's sitting idle half of the time, I'm not utilizing that to its most. And that's what visual allows you to do, is take that resource and maximize it, use it to its fullest, and sell around that capability. Cycle time reduction, improved due date performance. You'll notice here these numbers are quite high. 90 to 99% improvement in promises that we're making to our customers with regards to delivery of product. Work in process reduction, 10 to 60% improvement. The worst thing in the world in a manufacturing environment is for product to be worked on and then it sits and waits for the next operation. Visual scheduling cuts that time down so that we finish scheduling and completing the work on a sub-assembly that then needs to go to a higher assembly. So, and if it's got multiple sub-assemblies, we try and coordinate those so that they all finish at a given time. We don't want any of that sitting on the shop floor, taking up space and using up money. Finished goods inventory, we can reduce those from anywhere from 10 to 85%. And increased plant throughput, 10% to 40%. Throughput is measured in the visual system in dollars. We look at the schedule and how much throughput dollars can actually be produced based on a given schedule. Okay, I'm going to open up a couple of visual screens. The first one is our concurrent scheduler. That's what we're talking about today. We're talking about concurrent scheduling. This is standard product within Visual. You don't pay more for it. It's been part of core from the day of inception of the Visual product. Since 1992, this has been a product that we have cultivated, we have built on it, and it has lots of capabilities. You'll notice here there are multiple schedules. The standard schedule is the one that runs your shop floor. So why do we have all these other schedules? Well, in the real world of manufacturing, everything doesn't go the way that we typically want it to go. Murphy gets involved, people call in sick, materials get delayed, things of that nature. So what the concurrent schedule allows you to do is to model changes that you believe would increase your throughput, that throughput being dollars out the door. And whenever we can increase our production or throughput dollars, those throughput dollars fall directly to the bottom line. If I can build more product in the same amount of time as what is actually scheduled, the material cost gets pulled out of there and we simply look at the labor cost. And if I can build more product at the same labor cost, that improves my bottom line. So all of these other schedules that you're looking at here are what-if schedules. What if we increase capacity? What if we buy a new machine? What if we work some overtime? This tool allows you to model those so that you know that the decisions that you're making in terms of changes to the shop floor are going to be beneficial and not a detriment to the number of dollars going out the door. Visual The next thing I want to show you is a very simplistic work order. You know, in a lot of other systems, you've got to go through a lot of jumping through hoops in order to take your shop floor and expose it to a scheduling product. With Visual, that scheduling is built in. It is built into the main product. It always has been, and Visual has always been able to schedule. For those of you who have never seen this screen, the operations are resources. The light yellow cards are raw materials. The light blue card is an outside service. But the complete construction here of the structure of this engineering master actually facilitates scheduling. Very simplistically, you start at the first resource, you work your way down. So in this particular engineering master that we're looking at, I've got two sub-assemblies. Those two sub-assemblies are pulled over to a welding operation. So in a scheduling run, I can schedule these two sub-assemblies independent of one another. They come together at the CNC weld, and you simply start at the first sequence number and work your way down. The building of this structure is reflected in scheduling. The way that you build it is the way that it gets scheduled. So these two sub-assemblies can be scheduled independent of one another. We will try to our best in the Visual environment to make sure that both of these sub-assemblies finish at about the same time so that they can go together or very close together over to CNC weld. That'll keep these sub-assemblies from sitting on the floor taking up space and taking up dollars, inventory dollars. They get joined at the CNC weld, and then we complete the scheduling. Now, again, this is a very simplistic work order with a combined bill of material and routing. We call it a bill of manufacture. This is how we're going to make the product. Okay, so the scheduling of this product can certainly be done within Visual, and it's really the results of those schedules, as well as those what-if schedules, that we would like to take a look in a real environment with regards to these structures and the way that they actually play out in a manufacturing environment. And with that, I'm going to pass this over to Ellen H.
All right, thanks, Tony. Let's see, get my screenshot showing here. Okay, I'm sharing my desktop. I'm Mike Longo. I'm the president and shareholder of L&H Industrial. I've got Cassidy Hunt, the IT manager, and Nathan Kloss, which is our scheduling expert, here with me in case there's any technical questions later. Tony did a good job of showing how Visual works and what it's about. So I'm really here to tell you about L&H, how our company is, and how scheduling helped us move from a $17 million company in 2000 to an $80 million company in 2011. And we definitely could not have done it without finance scheduling. It's been a big part of our growth. So a little bit about our company. We're a leading aftermarket supplier for the mining industry, surface mines mainly. We do a little bit in oil field service and railroad equipment. We've been around since 1964 and came from an oil field drilling rig repair shop and have added in surface mining, being the world's leading aftermarket supplier of aftermarket spares for shovels and drag lines. So it's many varieties of products we work on, and we repair the equipment. We'll sell them new parts, and we'll also go out in the field and service them. So there's a lot going on in our shops. We've got about 750 active work orders as of yesterday. bounces around up to 1,000. In those, there's about 3,000 open operations at any given time. We're juggling about 186 different resources in our schedule. Like I said, the company started in 1964. Global operations really started in 2002. We use visual in our domestic plants, and they're all tied into one server that happens to be in Gillette, Wyoming. So anything we have domestically is working off of visual. We do a lot around the world. We ship to all of these areas. We've got operations in Chile and Mexico and Australia. We don't have visual implemented in those places yet. They're still doing it the old way, and we're frankly paying the price for it. But in the USA, we've got the main location in Gillette with about 200 people running off of it. We've got another location about 80 miles away that is running about 50 people, and then in Phoenix and Tucson, we have 2 other plants, and each of those is scheduling their own plants, plus we've got them all to where we can schedule them together because some products start in one location and go through other locations. This is a picture of a dragline, which is a large earth-moving machine, and we can rebuild or manufacture new almost any mechanical spare on that. The railroad machine on the lower right is a pre-gauger. That's one that we designed and we manufacture. So gives you an example of the variety that we are dealing with. Our typical resources, CNC, manual machining, welding, chrome plating up in Sheridan. We do mechanical services, painting, sandblasting, engineering. We have an engineering group of about 15 that's fully scheduled. Gear manufacturing and remanufacturing mostly happens down in Phoenix. We do field welding, machining, and mechanicking, so a lot of the work we do in the shops we can also do in the field if they don't want to bring the parts in. Metallurgical labs, and I could go on and on about the variety of things. Anything that has to do with fixing the equipment, keeping it running, we're basically going after that equipment and saying we'll support the entire piece of equipment. Business challenges, we need to manage about 12 product lines with over 15,000 part numbers. And in the meantime, we're also a job shop, so we're make to repair or make to order. So we're still have the job shop heritage where we're doing a few $1 million worth of job shop repairs. Along with that, we're doing manufacturing of our design parts and field services. We needed to improve our operational efficiencies and maximize throughput. In order to be able to grow, we had to be able to control these things. So as Tony showed on the work orders, now we can set those up, and the first time it might take you a few hours to get them set up, get them scheduled right, get the legs in the right place. But once you have it once, then you can just repeat that order next time. So something that may have taken you 5 hours the first time to get right, the second time in 5 minutes you're off and running again. So you don't have to do things twice. We lacked a solid concurrent scheduler to know what we were doing in the shops. Basically, the supervisor level did all the scheduling. So each supervisor had his own plan, and it came down to whoever was yelling the loudest. So as we grew, the only thing that we could get done was rush jobs. Anything that was routine, we had trained our customers that if it's a routine job, don't take it to L&H, they'll never get it done. We were able to overcome that with good scheduling. We still fit the rush jobs in, but you see what you did to yourself, because as soon as you plug it in and you rerun the concurrent scheduler, it shows you through customer service impact, which I'll show you shortly. It shows you what you made late, and then you can deal with that ahead of time, not after the customer's yelling that you were supposed to deliver your part. So our solution was visual manufacturing, concurrent scheduling, and throughput. We're also running business intelligence. We're doing barcoding, and we're doing that now through time and attendance. We're barcoding materials, and we're running time and attendance. You'll find when you go to scheduling, one way to create the discipline in scheduling is you have to dispatch. You have to be working off the dispatches, not travelers. And time and attendance does that automatically. That's something fairly new to us. We've implemented about 6 months ago, and it took the place of wedge and printed dispatches. Infor definitely fulfilled our requirements with a comprehensive solution and design. We've been working on it, like I say, since about 2000, and we're still working on it. As we grow, we come up with new ideas, better ways to do things, so it's been able to grow with us. One thing that Infor has that other people will say they have, I haven't found another company that's able to do this, but the concurrent scheduling, where you can schedule the person and the equipment and materials. And when you rerun that concurrent scheduler, it takes into account all three. So if there's a PO out there that needs to constrain that person from starting the job, it pushes that job out. If there's a piece of material and you're running short, it shows you that you're going to run short. You have to have all three. If you just try to schedule your people or you just try to schedule your equipment, you're only getting a third of the equation. So that I think is the power of visual and the concurrent scheduler. That's what makes it great. Increased sales, basically increased our throughput by 30% with less effort and man hours. We acquired 3 different companies, and the last 2 we went in and replaced other ERP systems that those companies had and were very passionate about. They were smaller companies, about 10% of our size. And when we took their system out and we put visual in, everything streamlined. We saw a 30% increase in throughput. People weren't having to work weekends anymore. And that's simply because of having a good plan and having the right people on the right thing. We duplicated that in another acquisition we did a couple of years later. So we're very confident that you can easily see a 30% increase in productivity, taking our scheduling and putting it in against other shops that are trying to do other things. Improved shop optimization. So we are a job shop. We throw manufacturing in there, but it does seamlessly handle the 800 plus different custom and rebuild jobs at any given time. And there's a huge variety and it changes consistently. So it's probably one of the toughest environments that you could try to schedule in. Reduce operational costs. So your automatic tracking, of course, when you're scheduling, one of the main things is to unload it. So through time and attendance, we're unloading it immediately. So immediately know what our costs are. We're unloading the schedule, and we've got everything captured real time, which keeps the new schedule in front of it. Everybody knows where we're at on those jobs. And improved customer service, on-time deliveries, that's huge. And we are still a rush shop, so we'll still throw a big rush job in and knock a bunch of stuff out of the way. The great thing now is, though, we see immediately what we did to ourselves, and we can deal with that. We can make that decision. Improved quoted lead times based upon real-time data. Our competitors are famous for giving delivery dates, telling the customer what they want to hear, and missing those delivery dates. We don't have that reputation anymore. The customers know that we're going to be very close when we give them a delivery date, because we can see forward, we can see out in the future and see where we can fit things in. Visual shows us our future and gives us the tools to increase throughput and customer service. That's really what it's all about in our ERP system is look into the future, plan it, and affect it positively, and you can make a big difference when you're taking that approach. Let's take a look. All right, I opened up. This is our real database, and here's a scheduling window. These are showing the resources. So each one of these is resources. It's a new guy. You can name these with people's names, or you just leave it together. Like down here, these are welders. This happens to be a view of our Tempe facility. This is all the jobs, and if you see white, where you see the white, that's open time. So this new guy, he doesn't have anything scheduled until out here on the 4th. And going on down, you can tell when you can put something in. So the first place you would go if you want to know if you can fit work in is right here. Because if there's white space, you can fit a job in there. It's open time. We can book it. The red means that it's scheduled to be late. Those red jobs are late. The yellow you see here, these are all machines down here. So of course they're open 24/7. These are people, so they're just in small blocks, and their shift dates change. So it really gives you a big picture. You can zoom in with this, get down to just a day. You can zoom out and see later, and you get a real picture of where you're at. And as you get this loaded in, you can kind of tell in the future what your loads will be. Go down here, that's all the machines. The yellow, what I did was I highlighted work order immediate, so I'll do it here. A lot of neat things you can do. So I highlight that work order, shows you that it needs to go through the pre-gash, the Craven pre-gash, and then it goes to here, and then it jumps over and finishes there, and jumps down to this shaper. So it shows you the equipment that's needed for that and how it's flowing through the facility. And if you would go up here, it would show you the manpower that it's grabbing to run that equipment. So it's very intuitive. You can launch from this right into your work orders. Our people look at this 3 times a week as a group in scheduling, and it takes them about half hour. And then, of course, the scheduler would be going in this screen every day. Now, in the scheduling screen, the thing that you need to keep clean is the throughput. So your throughput window is a place that if you're not managed, it makes it easy to manage the schedule and easy to manage what you've got going on. The first one you look at is customer service impacts. And what this tells us is any job that the due date on the sales order, the expected finish date on the work order, which is a computer calculated, is later than the want date on the sales order. And our coordinators are supposed to come in here, which these are all these sales reps or coordinators. Our coordinators come in here and look at it, and if anything's over 1 day past due, they should be dealing with it. They should be drilling into this job. And they can drill in right here just by double-clicking into the work order or the sales order. And they should manage that. They should go in and get that cleaned up. They know there's a problem. Something's happened that's made that job late. And same with next month. You can look and see what's going to be late next month, and they should be managing these all the way out. If you're a coordinator, your job is to keep these screens clean and get the things scheduled within schedule. So that's a screen they visit every day. So you're managing the exceptions. You're not managing all 750 orders. You're only managing the few orders that showed up on here. And you can very easily dice it down and give it to different people. Next one I want to show you is actual sales. So this is the actual sales for the last few months, and you can drill into this. This month is the one that would get a lot of attention. So we look at this and how much have we shipped this month? $6 million we've shipped. And you can, just by double clicking on the top here, you can sort it by the largest, the smallest, or smallest to largest. And you look for issues like this. These have shipped at no cost, so you can drill into them very easily and figure out why. That, along with this expected, the expected is really where you want to spend your time. So the expected sales is future looking, and it's looking off the due date and the sales order. The due date of the work order and the sales order. And so it shows, we're getting close to the end of the month, and we want to maximize our throughput through the rest of this month. Let's see. So we've got about 2.5 million left. We can drill into this and see what we've got out there. Can we pull anything in? Are we really going to get that much? Or we can go into the next month and see if see if anything in the next month can be pulled into this month. So you basically just drill into these and pull the jobs in and prioritize to try to get your maximum throughput. So you can look at it from a sales and a cash flow perspective. So that's the main screens that we need to keep an eye on. You're always looking at the scheduling window, customer service impact, and then your actual sales and your expected sales. And you can see the entire view from that. With that.